Hi, everyone. Thank you for joining us today for the Structural Elements of XR. Before I introduce our speaker, I have a few quick things to go over. Please take a moment to read our code of conduct. We ask that you be kind and respectful to everyone, including our speakers. We want the reactors to be a place that everyone feels welcome. Please ask your questions using the live YouTube chat. In the chat, I'll also be sharing some links that go along with today's content, as well as a link to our Reactor Meetup page if you're interested in checking out what other sessions we have coming up. Today's session will be added to our Reactor YouTube page in 24 to 48 hours. And finally, I will share a link to our Reactor survey. If you have a few minutes, we greatly appreciate your feedback. Thank you all again for joining us, and I will now pass it over to Thomas.
Excellent. And Corey, are you able to see my first slide?
Yes. Yep.
Okay, perfect. First off, thank you everyone for making this. It was a little bit of a challenge because usually I'm out of my home office, and our Xfinity folks gave us a little thing on the door that said, "Hey, tomorrow we're going to be making some changes, so you might be out of bandwidth for part of the day." So I immediately asked the great folks here at the Microsoft Reactor in Redmond if I could find a room and do the presentation from there. So hopefully we will have no technical issues or anything like that. But again, I appreciate everyone taking the time to watch this in real time, or for those folks who are going to be watching this afterwards on YouTube and in other places. If you don't know who I am or have seen some of the other presentations that I've done, my name is Thomas Lewis. I'm a spatial computing advocate within Microsoft's developer relations. And so we focus on all things mixed reality, augmented reality, virtual reality. We have been working with Babylon.js, which is a JavaScript-based 3D tool for the browser. So if you're interested in doing XR, Babylon.js is something to look at. We're actually about to release version 5 any moment now for you to take a look at that. And then I also consider myself a reality naut, which is a person who is just excited about this space and always learning. And I think one of the things that everyone will probably come to understand is that we're still at the very beginnings of all these things that we're talking about. And so I always kind of think of Neil deGrasse Tyson when he would do Cosmos, and he talked about his job. And one of the things I really loved is they talked about how they may think something is true, and then something changes and they're okay with changing their minds about it. And I just found that very comforting and interesting, because I think a lot of times we like to think, especially in tech, of these hard, fast binary rules, like this is the only best practice. And what we're finding is, yeah, we may think that this is a best practice at one point, and then at another point, we may do something a little bit different. So I would love to think that everyone on here can be a reality naut as well. So if you're interested in contacting me, want more information, or just have a question or an idea, feel free to DM me. I'm Tommy Lee on Twitter. Yes, I do get the drummer from Motley Crue's DM sometimes, which are really unusual. But I do really appreciate talking with you all and understanding what are other types of things that we can talk about through this channel as well. So this is going to probably be a little bit different than the typical conversations around building mixed reality solutions, because a lot of times what we do is we immediately jump into Unity, change some preferences, write some scripts, drag in some prefabs, and kind of do things that way. And so kind of in a very much a recipe style thing. And I subscribe to 2 magazines, All Recipes and Living. We're going to be probably more on the living side. So Martha Stewart, how she doesn't always have recipes in living. Sometimes it's more conceptual, of like how to throw a really wonderful party, or how to do container gardening and things like that. And so we're going to focus a bit more on the conceptual elements here today. Just have to side track of, Martha Stewart. Wow, how have things changed? Quite a few years ago, if you would have said, "Yeah, Martha Stewart's going to be, hanging out with Snoop Dogg all the time and doing a lot of different businesses with him," I don't think I would have thought that would have happened, but it did, and that's absolutely awesome. And again, it just goes back to the ability to kind of change and be agile in our thinking, especially as we are reality knots. So to talk about some of the conceptual elements, there are a lot of different tools to help support the things that I'll be talking about. So for example, Microsoft has its MRTK, Mixed Reality Toolkit, and it's open source. And so it not only is built by us, but also other folks have contributed to it. So Magic Leap folks, for example, have contributed to it there. But there's a lot of good stuff out there. I don't want you to think that all we're going to do today is talk about Microsoft-ish stuff. Because the elements that we're talking about, they're related to anything you use. So for example, if you're using Snapdragon Spaces or Niantic's Lightship, or you're using Oculus's SDKs, what you'll find is there's a lot of similarities here. Now, they may have different names to them, but they all have basically those similarities. Also, too, in this discussion, I'll probably just talk about AR-related things more than VR-related things. But again, a lot of these things will pollinate across each other. But the good point is you just have many choices today, and many of them are open source. And so what we'll start to see is just more and more of these kind of things that we're talking about. I'm only going to give you a handful of these structured elements, but you're going to see more and more of these as we grow, and as, for example, the metaverse comes, because then we need other structural elements to support metaverses, such as portals, and being able to kind of take avatars and work with avatars through different types of metaverses or microverses, or however you would like to talk about it. But as one of my favorite memes says, many choices, much wow. So the first thing I want to talk about, the structural element, is the app model. If you are a designer, please don't tune out or walk away during this part, because I think that it's very important that everyone understands that everything has an app model in the way that it works, and it can kind of define how things work, and for you understanding what you may have to build versus what you may have within the development environment. And so in an app model, like for example, for HoloLens, what we do is we place an app in the world to just start it, right? So we will put the app there. Usually it's a click, and then the experience will come up in front of us, or wherever we really want to put it. And then we're going through this process of figuring out, like, hey, is this running? Is it suspended? Is it not running? And allowing us to kind of build scripts off of those things that happen. So, for example, if we are done with a particular experience, we may want to go ahead and save the properties of that experience. But also, too, we might see the different types of programming models that they can act very different. So, for example, if you look at the bottom left, you may launch an app. And when you launch that app, it doesn't mean that all the other apps go away. In fact, it's not unusual, especially when you've been doing a lot of work, that in the room that you're in, you'll just see all of these different 2D and 3D, experiences that are still there. And so sometimes you have to really just go ahead and completely shut it down to make those things disappear. But most of the time what's happening is that those other apps that are there, they're in a suspended mode. And so they're not taking up, much resources. if hardly at all. But they could still exist there. So your kind of environment that you're looking at can get, cramped up with all of these different things there. And so you may want to build in a way so that when you get out of an app or an experience, that thing will go away. But we do, as you see in the bottom right, have the concept of background tasks, right? So for example, we could have background audio continuing to run even though we're not, prioritizing that particular app at the time. So again, most of the programming platforms out there have something that's very similar to this, but it's something that you definitely want to understand because a lot of times it will your experience will vary based on this app model, and also to understanding like, hey, why, what resources are being used right now, especially as we come out with devices that may be much more memory constrained. The second concept I want to talk about is the holographic frame. And here you can see an example of this where the individual is looking, that's the frame by which they can see things, especially holograms. Now, most likely, you won't see a full 360 view of where you're at because technology just isn't there yet. But it's very important to understand that we have this holographic frame, and there's some kind of design decisions and developer decisions that we have to make. For example, do we really want to render and represent the entire 360 world, or do we want to just render what's in that holographic frame? Also, too, how do we design for this? So, for example, if something is sort of outside of that frame, how do we let someone know that that there's something that actually exists? Now, good way of doing that is either, you have a pointer, and so you're telling people to look at that area, or hey, if it's that you want a bird to talk to them and like a mascot maybe, you have the bird chirp, and then we will naturally, of course, because we're probably in a room and not assuming that a bird has come through the window, we'll look up there to do that. And you want that to be natural. What I highly suggest you don't do is to have multiple things making noises and a lot of different things pointing at each other. Give someone, especially if this is the first time they're having the experience, give them one thing to do, because what's going to happen is, and I've seen this before, a person will put on a device and then all of a sudden they're just looking around like this because they're kind of worried that they're missing something. And this is especially true if you don't have sound. And this is really important when it comes to VR worlds, because in VR worlds, you can become very sick by constantly just looking around. And for the longest time, I used to get very nauseous in a VR device. And once I stopped kind of trying to do the look around and everything and just kind of naturally kind of go where the experience was taking me, all of a sudden I found that nauseousness, totally went away. Now, of course, everything in mixed reality is built on a coordinate system. So you may be familiar with XY coordinates, but you now have a nice little Z coordinate as well. And this is how we align everything. So typically, for example, if you were to look at your X, Y, and Z coordinates when you first put it on a device, you're put at 0.0.0. And you can see every time that he comes back to his original destination, it goes back to that. And then the way that we can kind of provide locations for other things is based off of these coordinate systems. So you can see there the 2D element on the wall, the orb that's kind of suspended over the table. And this just allows us, again, to have sort of coordination between elements. Now, those individual elements can also have basically their own coordinate systems if that's what you want to do. And the thing we have to be very careful of is that those coordinates can change over time. And so if you're not familiar with mixed reality development, a lot of times what happens with these coordinate systems is that there will be this drift that happens. So where you would be like, hey, I perfectly put it at this spot on the table, It may over time move a bit because depending on how the coordinate systems are connected together and some of the work that you can do there. But the coordinate system is very, very helpful for you because this is going to dictate, where things are. Also, it's done by meters. So for those of us in the U.S., we're gonna have to get a little more familiar with the metric system, which I honestly don't think is a necessarily bad thing. And by the way, if you like these images that you're seeing here and you're like, wow, where did this come from? This came from an app called Designing Holograms that was built by some really wonderful people in the mixed reality dev ecosystem team. And my team gets to work with them quite often. And they built this kind of tutorial that either A, you can read in the docs, I'll give you a link to it, or if you have something like a HoloLens, you can put it on and it allows you to kind of go through this training. And so you learn about a lot of these things, but definitely worth checking out, called Designing Holograms. Now, one of the things that defaults naturally is that when you put on a device, again, like a HoloLens, you will do a room scan visualization. And it kind of looks like this, right? You see all these different polygons because that's how we render out shapes in this world. And it provides the ability to kind of understand where there's boundaries at and where there's objects and things like that there. This helps to make sure that, hey, you don't, walk past a wall or you don't place things around the wall. It helps though also with occlusion. So for example, if you have a orb, let's say, and it's behind the couch, but it's peeking over, that's something that room scan visualization can help out because it knows that there is something there and it needs to occlude a hologram that you've created. And what's great too is with things like spatial mapping as a part of it, we can understand a bit more about the room that we're in or the environment that we're in. And the thing is that the more you use the device, the more exact it gets. So, for example, the first run through, it's kind of doing sort of a quick scan of where everything is at. But as you move around the room, it will continue scanning and it'll continue to provide much more clarity, much more distinct polygons and a lot more polygons. And you can either do this, just naturally through walking through things, or you can do it from a developer perspective and say, hey, I want to do a much deeper scan. Now, the thing to consider is that, the more deep the scan, the more data and, space on the device that it may require. And these can become pretty big. In fact, a lot of times, if you run out of space on your device, what people will do is tell you, go ahead and dump these scans that you created because they are probably using up the most data to have these scans. So what you want to do is you want to kind of have a balanced portfolio, as I like to say, and kind of get the scan you need, but don't necessarily overdo it. And you also are going to have to make some performance considerations here because what can happen is that you can continually be scanning and more you're trying to also have holograms and things, and interactions and stuff like that. And it can be just a bit too much for the device. So this is one of those things where I always say, practice, right? And prototype and get to really learn and understand kind of what those boundaries, may be for you. And so room scan visualization, something that definitely happens by default with spatial mapping. We get a lot more of what we can do with that. Now, one thing that's actually really cool is something called scene understanding. And this allows us to take kind of the spatial mapping that we were talking about earlier and kind of take it to the next level. So here, for example, what we can do is the room, the way we can think about it is that this is a scene, right? But within that scene, we have particular structures that are identified. So it's kind of metadata for a scene on top of what we would get with just spatial mapping. So here, for example, you can see that it knows what a wall is. It knows what a floor is. It can see the ceiling as well as what is a platform, right? So anything that you may want to be able to put something down on. And what's nice about this is, for example, you can start to build really interactive experiences, right? So you can actually have, for example, a person sitting on the couch because it knows the system knows that it's a platform, and so it has some assumptions that it can make. Also, too, if you are if you have no gravity within the scene, the ceiling, most likely will keep you from going through it because you will have an understanding of what a ceiling, will be. And this is great too, because, for example, we can create scene blocks, which allow us to, for example, if we have a 2D screen that we want to place along a wall, we can absolutely do that. And what it can do, because we understand the scene way more than we did with just a simple scan, we can also have it aligned to the wall, or we can have align it to the television, right? And the way that it moves. And then, of course, with platforms, we can make sure that if we, have our favorite garden gnomes statue that we want to put on our dining room table, we don't put it on there and it just, falls through. That again, it understands that there is a platform that is there. Now, there's also different core things that we probably will want to use as, again, you're working with things in real life, because that's what a lot of the AR work we do, and you're starting to see a lot of this happen as well in VR pass-through. And so one of the things we have and many other folks have been building are spatial anchors. And so this allows us to take a hologram or an object and put it in a particular place, and it stays there. So, let's say you go to Houston and you go to a botanical garden and you put your little garden gnome statue. By the way, I love garden gnome statues, so that's why you'll hear me talk about them a lot. But you go to the botanical garden, you put the garden gnome there. Then a year later, grab your device, go back to that botanical garden, that gnome will still be there. And that's spatial anchor. So this is a way for us to kind of lock objects to the real world as it exists. There's also a lot of other cool things you can do with spatial anchor. So for example, a lot of folks are thinking about and doing wayfinding. So what we can do is we can put spatial anchors in different places around the world, and in our world. And then we can also too make sure that, or we can figure out, hey, how do I get to that next thing? And so I think this is really going to be something interesting when, the kind of the glasses form factor becomes, more prevalent, in that, if you are trying to figure out like, okay, I got to go get on an airplane, how do I get to my gate very easily, instead of having to like read everything, or maybe we can translate it as well at the same time, because we can use cognitive services as well as a part of what we do. So things like language translation, object identification. That can be a part of it as well. So we can run, machine learning, algorithms to kind of figure out like, what is this thing that I'm taking a look at? But with spatial anchors, there's a lot of things that you can do there. And then we also have something called object anchors. Object anchors are, whereas spatial is kind of worldwide, object anchors, of course, is connected to an object. So here on the right-hand side, for example, you can see where we've put a hologram on top of the items within this car. And so this becomes very important, especially like if you're building things for frontline workers, right? Who maybe are learning. They're on the assembly floor, and this is the first time they're learning how to build an engine or how to put something together. And what we can do is we can actually make it where they can see like, oh, you need to put this particular screw in this particular place. And then when you start to think about connecting it with spatial anchors, now it's interesting because what could happen is if you don't have that screw, you can ask, via voice, where is screw number 75941? And then you can look over and it'll show you the box at which those screws are in. And so again, interacting with the real world in such a way that feels very natural. And if you've been a part of any other kind of conversations or business value conversations, you're seeing more and more that people learning this way versus learning from a 3-ring binder or what have you, learning in kind of a 3D world actually makes retention much, much better, right? And we've seen it anywhere from 30% to 70%. When we look at folks that we've been working with around academic, people have pretty much shown that they get a grade higher as they learn using 3D versus not. And if you're wondering why that is, it's because we are 3D people. We actually, everything we see, everything we do is involved, with 3D. Our eyes are very much 3D aware. Even our, ears are 3D aware. But what happens is we've gotten so used to computers and 2D. So there is this cognitive load that it takes to kind of learn, because you're having to flip back between 2D and 3D. Whereas if you're learning in 3D, you're more likely to not have that cognitive load. And so that's why we see people being a grade higher when they do case studies around this stuff, which I think is pretty fascinating. And then we also have remote rendering. This is something that we're going to start to see a lot more of, especially with the metaverse implications and the impending metaverses that will come. So what remote rendering does is allows you to take a 3D object that is very, very large, right? So you have here an engine, for example, that is 100,000 polygons. That's big. So if you are, talking around the world to your distributor of engines, and you want to be able to kind of take a look at it in detail, getting 100,000 polygons over the wire, even with the best of bandwidth, it's going to take a long time. Now, what you can do is you can do some scaling down, or what we call decimation. And with decimation, you're bringing it down. But what happens typically in decimation is you lose a lot of the fidelity. So here, for example, you can see the difference between 100,000 polygons and 100 million polygons. It's a very different look. So with remote rendering, what we can do is we can take these high scale images, decimate them in such a way that it still has the fidelity of the high definition. Now, this is something that we particularly do it in the cloud. We don't do it on device because the cloud compute is quite expensive. Not from a cost standpoint, but from just having to do the decimation and putting these things back together. It can be very expensive computationally. So in that instance, you want to use something like a cloud service to do those kinds of things, and maybe support those GLTF files that are already up in the cloud for you. And so this is great because it takes these 100 million polygons, it brings them down to quite a low amount of polygons. And this is very much helpful because when you start doing large scale 3D projects, you are typically given a polygon budget, right? So you don't get to just, it's kind of like building an app. You don't get to assume that, someone has like the most high-end powerful machine out there. You have to assume that like, hey, there's going to be some folks who have powerful machines, some who don't, some that are in the middle. And so this is really good when you have to kind of make those same decisions as you would an app or a website as well, that you want to kind of make these things much smaller. Now, I want to talk a little bit about spatial sound. I'll try to keep this not as ranty as I sometimes get on this, but one of the things that I've seen when I talk to a lot of folks who are building out projects, the last thing they tend to think about, there's two things they tend not to think about that we really try to help support. So one is inclusion. So how do we think about folks who are using these tools that have disabilities? So we think about that a lot and then provide guidance around that. Two, spatial sound is critically important, especially if you are trying to build a professional application or a professional experience. I find a lot of times folks just don't even think about this, and you can tell because when you go through when you are going through that experience that they've built, it feels very odd. And sometimes, like they won't allow people to speak commands, which I think is one of those things that we want to do a much better job of because. In my experience, again, maybe it's not with everybody, but I find that a voice command is much better than some kind of custom gesture that you're doing, right? One of the things that we learned from HoloLens 1 to HoloLens 2 was this gesture, which we thought was like, oh, that's a real easy one. It is very easy to find. You'd be surprised how many people were challenged to do that gesture. When I would do demos all the time, I would find a lot of folks who would have struggle with that gesture, and I would even put my hand in front and do the gesture, trying to get it to work for them. So I'm very much a proponent of making sure that we include spatial sound. And remember, we talked about this earlier, right? Where to keep people from constantly having to look around to make sure they're not missing anything, that they can actually maybe hear the bird in the background or hear something in the background and know, oh, I should probably turn and look over that way. I understand not everyone can afford a spatial engineer for the work, but absolutely, if you're trying to build something professional or you want it to appear professional, definitely create spatial sound because you will find that some folks. I was talking to a student group that was building out an experience. And I asked them how do they handle folks who are visually challenged in their application? And it kind of threw them for a loop because they kind of thought that like, oh, well, this is a HoloLens, so it's got to be visual. No one's going to get it if no one's going to buy it if, they have bad vision. And interestingly enough, we showed them folks who are playing Xbox, first shooter games who have no vision. And so they were surprised by that, but then they understood it. And I was really impressed because 3 months went by and one of them saw me in the hallway and said, we added a bunch of new features using spatial sound and using voice. And we think we've made, an application and experience that is just even better, not just for folks who are hearing impaired, but for folks who, just maybe hard of hearing or have troubles, doing gestures and things like that. So yes, if you ever have me review your experience, 9 times out of 10, I will be bringing up spatial sound if it's not there because it's such a key important thing. And so I apologize for the rant on that, but I do think that it's very important. And what we would love to do is in one of these, sessions in the future, I'd love to do a presentation just on spatial sound. So if that's something of interest to you, let us know. All right. So what I wanted to do was to give you some best practices based on some of the work that our team has done and some of the projects that I've been involved in and have researched. And so this is just a lot of, things to consider. So one, don't assume that a toolkit supports all platforms. Because sometimes they may say they support all platforms, but they support some platforms really well and some not so well. So you definitely need to kind of check that out and be careful. Also assure that your cloud services are vetted. One, make sure you can afford it, right? Because a lot of times, these things are done on a very, small scale, right? So, it's only a penny a polygon. Well, when you have a 9 million polygons that you're working with, that all of a sudden becomes a lot of money, if that's the case. And also make sure that it works the way you expect it to. I remember looking at a particular cloud solution feature, and I expected it to work one way, and it did not work that way at all. And we had to kind of change how we thought about our approach. So make sure that there's always usually a free way of getting some services when you're starting out, and so definitely get those free services and check out if that cloud service is working the way you think, and of course, give it a prototype. Just because a device has a particular sensor, don't assume that it's always going to be available to you. So a lot of times, for example, people will be like, oh, you have eye tracking, so I want access to all the eye tracking that's happening. That's not always the case that you will have access to that. A lot of times it's because of privacy considerations, but a lot of times you may see that, a device, it's like, oh, it's got this sensor, that sensor, and it may be something that, the vendor who created the device has access to, but maybe you don't. So always make sure that you ask. Another key important part, especially around performance, is where does the compute happen, right? Is it coming from the device? Is it coming from the software? Or is it, coming from the cloud? That's going to be very important, and you're going to need to make those trade-off considerations. The devices we have are fairly fixed, right? You usually can't open one up, add some more memory, and you're good to go, right? Or add a quote unquote another graphics card. A lot of times you have to kind of make that balance, and so you'll have to sort of look at the portfolio of things you have and see where is that compute happening and take advantage of that. And then also make sure that when you're first starting out, identify a target on the mixed reality spectrum. And what I mean by that is figure out what you want to do for one target. So if you might focus on augmented, you might focus on virtual, you might want to do web, or you might want to focus on mobile. But if you try to do all of them, because I think a lot of times people think, oh, well, I'll use Unity and I'll just churn these things out into all these different things. That's going to take time. It's going to take cycles for that. And not everything's going to work exactly the same. So you're going to have to do some extra work there. So I just ask people to always kind of, if they have the ability to focus on one, and then after you've got that, then you can start adding these others. But we don't have sort of a, one thing to rule them all. I think OpenXR is probably the closest thing to that. But again, I think as you get into this, because this is a very broad field and a lot of learning is happening, as we go, maybe do, that particular focus. The things that I talked to you today, they're in our documentation. You can go to aka.ms/mr-docs. And we have all kinds of stuff up here. The thing that's nice is we have put it in such a way that if you're more focused on design, we have content that is more focused on design folks. If you are a person that uses Unreal instead of Unity, we can support you there as well. And so we can show you the samples for Unreal versus the ones for Unity, or if you want to write, natively. The other thing that's very cool here is we have added information for IT admins. So one of the pieces of feedback we got a lot, especially as we were dealing with academic folks, was that the computer science department would, order 50 devices, let's say. And those 50 devices, usually don't go directly to the comp sci professor. It usually goes to procurement, right? Which is usually under the IT staff. And so all these 50 devices would show up on their loading dock. And people were like, okay, what do we do from here? How do we manage these things and stuff like that? So we actually have for IT admins what folks can do. So for example, if you're like, well, we want to put a image on each and every one of them. How do we, do that kind of thing? That's the kind of stuff you would find in that section. So take a look at the MR docs. It goes into greater detail than I did here. And then if there was anything where I go, like and subscribe below, this would be it. I would love if you all, as a part of the community, would go to aka.ms/iwantmr And what that does is that gets you our newsletter. And our newsletter only comes out once a month, so we are not going to spam you. We also make sure that there's good content in there. So our goal is not to have you, purchase a HoloLens or a Windows mixed reality device. If you want to, definitely let us know. We're glad to help you with that. But really, this is us taking a lot of the content that you see here. In fact, you can see that this particular series that this session is a part of is actually a part of a larger Journey to XR series that's hosted by April. And so if you want to kind of be in the know of like, hey, what events are y'all going to be at? That we do that kind of thing. But we actually put all of our content here. So if you're like, hey, what's been recently added, to the docs? We put that there. If we do a new series, on YouTube or here at the Reactor, it's there as well. So if you get a chance, go there. I want MR. This helps us out a lot because we get to kind of understand where you're from. We use this for data as well. So for example, when we think about what countries we want to go and do localized content in, we look at the folks who say, hey, I'm from Japan. And if there's a lot of folks from Japan, we want to help those folks out. So again, if you want to do the like and subscribe for us, I Want MR is a great place. All right. Well, I know that we went through things pretty fast and pretty quickly. I want to let you know again, please feel free to reach out to me. I'm again at Tommy Lee on Twitter, Thomas Lewis on LinkedIn. There's quite a few places that you can find me. I'm more than happy to, have you in my DMs and, talking about your thoughts, comments, things that you want to see. If there's feedback that you want to give to the product folks, or just your ideas. We love hearing from you, and we love hearing from the community. So again, I want to thank you for your time this morning, or whatever time you're watching this, where you're from. And have a good rest of the day. And what I'm going to do is I'm just going to get rid of my PowerPoint here and just make sure that if there are any questions. Looks like we got some. Talk to us in the MR community here, aka.msmr forum. Yes, if you have questions, the forums are a great place to have those. There's a lot of different folks, not only advocates, but product team members and our dev ecosystem friends over there as well, who are looking at those all the time. So if you're looking for help, that's a great place to ask questions. Peter, you asked, is the scan being done with HoloLens? The answer is yes. So what you saw, the HoloLens is doing that. And by the way, it will continue to scan over time, right? Because the more scans we get, the better that the meshes look, and the more detailed the meshes can take a look. And Fridge Basket totally already said yes to that. So awesome. Fridge Basket says, do world locking tools make spatial and object anchors unnecessary? I don't think so. I think the way I tend to think about it is that they are just extensions of these things. And so I think what will happen is the world locking tools will become more and more. Let me take a step back. I think we will use world locking tools as the name and nomenclature than some of these other things. And so I think that we're still at that part where we're figuring out, like, okay, how do we name these things? How do we stay consistent? And this is one of the things that me and my team, we definitely want to work on, because if you're working with our good friends at Magic Leap, for example, hopefully we're saying the same thing. I don't want us to get into weird, nomenclatures of, well, they call it this, but we call it this. We should kind of get standardized on it. And that's why I kind of love the WebXR stuff, where we're actually going through the W3C and we're coming up with these names, and they're not going to, change based on what folks are interested in. Peter, can I use a 360 image as a source for my scan, and what software would facilitate that use case? That's a good question. I would like to say that I know that answer fairly well. From what I have, I have a friend who does 360 scans, so I'm trying to remember some of our coffee chats here, and I can't remember the software that they ended up using. Um, but there was something that allowed them to do a scan with another device, right? So what they wanted to do was instead of it being a HoloLens where a person had to spend a lot of time kind of moving real slow to get that information, they just wanted to use a camera to get those. So one of the 360 cameras that are out there. That's a good question. I'll try to find out what my friend recommends, and then I'll put it on Twitter so that other folks can see that. Humberto says, I'm looking forward to a time when we have productivity tools in an XR environment. Yes. This is and so we actually had something called Maquette, MAQUETTE.ms. I'm not quite sure if it's still available or not. It's not being worked on now, but it had really great tools for being able to kind of create scenes and create environments. And what was cool about it is you didn't have to do any coding or anything. You just had your hand controllers, and you could draw out things and scale out things. And then there was a Unity plugin that we had that would allow you to drag that scene into Unity, and then you could start within Unity, kind of creating the things you want, right? So, oh, I want this, couch to have a little bit more bounce to it, or what have you. Or, hey, I want to put these sounds in place because we're showing a barista how to make particular drinks and things like that. So I think we're going to see more and more. There are folks that are already doing these kind of things. Eighth Wall is an example of one. I've seen some others where it makes it very easy. Like if you had a museum where you can basically just like say, hey, here's a spatial anchor, plop it here. I can create a really quick and easy I forget what those museum identifiers are that explain like what the portrait looks like, or who made the portrait, and things like that. So I totally agree with you, and Humberto, I think that will be, a lot of people keep saying, well, what's the killer app? And I'm like, I don't think it's going to be a killer app. I think it's going to be a really easy way to build these solutions that don't require you to be a developer, but is smart enough so that when it is created, a developer can come in and create objects and be able to program against those objects. And yeah, I got lots of opinions on that, so I'll move on from there. And then finally, the last one, Natalie says, I am more of a VR designer. What's the best use cases for AR besides 3D training, which seems obvious? Yeah, training is probably one of the big ones right now. The other thing is simulation. So a lot of folks are kind of taking Azure digital twins and this space and kind of putting those together and starting to go, okay, how can we think about these types of things? The other thing is how to find thing. So, for example, there's I forget the name of them, but they build elevators and elevator systems. And what they do is they will have a building and they'll create a digital twin of that building. And the digital twin will kind of help them understand where problems might be instead of them having to like shut all the elevator bays down to kind of figure out what the problem is. And then the cool thing is they can walk in and using things like spatial anchors, they can find the patch box that they're looking for. And then when they get there, they can have someone who is an expert, right, who can see the box through their AR device, and can kind of even annotate and go, see that little switch there? You need to like turn that off first, and things like that. So I think that there's those kinds of things. Being able to put things in a place to get real world characteristics. So, for example, IKEA. Being able to we were in an apartment for a little while. We moved not too long ago, and it was great. We found the couch we wanted, And we were able to place it in our living room and see it there and understand like, oh, okay, this is going to be bigger than what we thought, right? And then when we moved into the new house, we were able to take a lot of the different pieces that we had, and I was able to show my wife. So my wife's kind of notorious for like, I want to move this over there and move this over there. And I'm like, let me show you what it will look like. And then you tell me if you want me to do this. And it has saved me some pains in my back, for doing that kind of thing. So yeah, there's a lot of different types of things that we're seeing, and we even built our own first party solutions around things like, again, simulation, guides, guiding someone in through a particular process, layout, which allows like someone who wants to build out a factory floor to say, hey, we're bringing in this M3791 machine. Where are we going to put it? And, like I said, the last thing you want to do is bring in a machine and all of that, and then it doesn't actually fit. So there's a lot of good stuff that's coming from there. So with that, I want to just say thank you again very much. I really enjoy, sharing this kind of things with you. If you're wanting to find out more stuff like this, please let me know and let us know at the Reactor, and we'd be glad to do these things and based off of what your interests are. And hopefully all of you, I'll see you at Tommy Lee on Twitter. I always talk to reality knots like yourselves, and I want you all to enjoy this space as much as I do. So with that, thank you very much, and you all have a good rest of the day, evening, or wherever you're at. Bye.